1, 2, and 3, and then we're stopping. Abby Grace, raise her hand. Let's see which one she was wanting to do. Absolutely. And she can have a point for that. First of all, she recognized that the square root of 169 is 13. So she recognized that perfect square. I'm also impressed she knew to leave an M under the house. Why did Abby Grace leave an M under the house?
Because you couldn't pull another one out. Because I know what I'm trying to say, but I don't know how to say it. Like, okay, yeah, it's 5, and you have to have like a set.
I'm waiting for a certain word, and I'm going to give it to you.
Yeah, I don't know what to say. You have to have like a pair. You have to have 2 of them to be able to pull one out. I don't know how to say it.
It's blah. And then Travis almost had it. It's odd. It's an odd power. Any odds are going to have leftovers. It was the end of the 5th. That's why there's a leftover. 8 is even. There are no leftovers. Anytime there's an odd exponent, that's when we end up having someone left over and we put it under the house. Okay, let's back up to number 2. I need 2 things that multiply to 20. Okay, 4 and 5. Okay, so someone want to, if it's 4 and 5, 2 DJs are on my nerves. If it's 4 and 5, then what's left over and you can get your point. XY squared. Z to the 3, and then what's left over, Drea? Okay, again, x to the 3rd, y to the 5th, those are odd numbers, so I knew I was going to have an x and a y left over. 6 is an even number, that's why I don't have any z's left over. Are there any questions about number 2? Okay, number 1, I need 2 things that multiply to 56. If you say 8 and 7, I'm going to be mad because neither of those are perfect squares. 4 and 14, Drea's getting her up another point. 4 and 14. So I know it's going to be 2 and a 14 because the square root of 4 is 2. Now to deal with those A's, B's, and C's. Abby Grace gets her group another point. A, B squared, C squared with a C lifted in the house. Why is there a C lifted in the house? It was the one odd exponent. It was C to the 5th. Are there any questions about these 3 math workshops? Okay, then let's talk about today. Go ahead and go to your cute handout. We are actually, so Andrew spoiled my fun. But of all class periods, I knew 3rd period was going to be the one to notice because y'all actually use them the most, which is good. That's one compliment I should give y'all. That things changed today. I took the graphing calculators away. You're not in trouble. There's not one missing. There's nothing wrong with them. It's just for this section and this section only, you can't use your graphing calculator. So if you have your own personal one like Abby Grace does, you better not have it out when we do, well, I assume she's not going to cheat right now. She might want to put it away to not be tempted. That would be smart. But as for this next test, she's not going to be able to have a graphing calculator. Now, table 1 was smart, and they can have an extra point for this. They said, well, you know, I use my calculator to do easy math too, just to check myself. That's fine. If you want an easy math calculator, I have some you can borrow or you can bring your own. It just can't be graphing. Just this one test. You can't have a graphing calculator. Just this one time. Yes, dear.
Why exactly?
Okay, so that's a good question. So the whole point of this section is actually to kind of intuitively know how to graph. So we would never learn intuitively how to graph if we always had a graphing calculator. Because we just say, well, I don't need to know. My graphing calculator is going to do it for me. So for this section and this section only, since we're learning how to intuitively graph on our own, and we want to identify general shapes on our own of how a graph should look, we're not going to be able to have our graphing calculator. It's actually not going to be a big deal. And after today, and we've actually already done some stuff, so it's going to be great. So let's talk about what we tested on yesterday. We tested on adding, subtracting, multiplying with polynomials. We had some stuff to review on exponents, which was concerning, but anyway. We did long division, synthetic division, and then the last couple of problems asked about like degree, leading coefficient. We didn't get to multiplicity, but we could have. we actually have been graphing. So Miss Compton jumped the gun on last Friday and Monday. We've already done some graphing problems. So graphing is not a big deal to us. But we're going to focus on a different aspect of graphing today. We're not even going to talk about zeros. We're going to talk about something completely different that we should focus on with a graph. Okay. What vocab word means the same thing as highest power? Say it again. What have we been talking about lately? What's one of the words we've been using a lot lately that sounds like highest power? Whew. Okay, and that highest exponent, okay, we're getting closer. What are we calling that? Degree. You can have a point. So I'm going to write in the word degree up here on the top of my handout. That way, in case I see degree, I remember, duh, that's the highest exponent, the highest power. They all three mean the same thing. They're synonyms. Okay, so you and I have been listing the degree lately. We're not even going to talk about graphing it yet. Let's just go ahead and list the degree for this first problem. What is the degree? 4. And Caitlin, you can have the point if you'll tell me that leading coefficient. Be specific about the sign. Positive or negative? Thank you. Your group can have a point. Okay, 6. You know you're in need of points because you're the quiet ones. Would you like to tell me the degree and the leading coefficient of that second one? The highest power and the number in front of that. Okay, table 5. Let Jemiah do it. She had her hand up forever ago. What's the degree? And the leading coefficient? Positive 1. Her group can have a point. Let's actually save that fraction one till the end. Let's do the fourth one instead. What's the degree on this one and the leading coefficient? 3. Table 1 gets the point. And then the hardest one is this one because of the fraction. Be very careful before you tell me that leading coefficient. What is the degree and what's the leading coefficient? The degree is 6. Yes, and Abby Grace gets the point, and Landy, you can have a point too, because you did tell me the degree. Leading coefficient's negative 1/3. Every class period someone is wanting to say negative 1. You might want to rewrite this equation to prove to yourself that it's negative 1/3. Hopefully you just saw that. If you need to write it, you can. Okay, so today we're going to talk about what we're supposed to learn from the degree and the leading coefficient. Again, I'm not even talking about zeros or multiplicity today. Seriously, we can learn so much about our graph just by knowing the degree and the leading coefficient. I already know what kind of a sketch to draw just by hearing those two things. Okay, let's talk about some things. Notice these two. Tell me about the degrees. Look at what I'm covering up. Tell me about the two that I'm showing. What about their degrees? So even. 4 and 5 get a point. So these two are odds. These two are evens. And then tell me about the leading coefficient in the top two versus the leading coefficient in the bottom two. Positive. 2 and 4 get a point. Whereas these two are negative. So today we're seriously focusing on, is it a positive? Is it a negative leading coefficient? And then, is the degree even or odd? Apparently, the degree even odd and the leading coefficient being positive and negative is going to make a world of a difference. Okay, here's your free guess of the day if you want to. If you've got it right, I'll give you a point. Again, you're not supposed to automatically know this, so it's fine if you don't know the answer. Any guesses as to which of our 4 graphs should go with this top left picture? Like which picture? Which one? If you want to hold it up and I see you got the right one, I'll give you
Everybody
point.
hold up a different one. Everybody hold up a
You can't do that, then I get confused.
No, but then they all. One of us get it right, yeah.
Which one? I can't see what you're holding. Yeah, I want to know which graph goes with this one.
No,
Yes, Jerry, you can have a point. No.
No, I got one graph. I'm sorry. I'm sorry. Can we try again?
No. We'll just do one per group. That way we don't spend all day on this. We'll move on with our life. Travis, y'all want to guess one? DJ, y'all want to guess one? It's a 3-point. Which one of the 4?
I guess
Which one of the 4?
Is it this one?
No. Y'all want to guess one? Going once, going twice. I can't tell what he's holding up. I can't tell.
Yes.
Is yours the symmetrical one?
I mean, it's going.
Okay, then yeah, I think so. Okay, let's move on. You can have your point, table 3. We're gonna put this one here. And I'm actually gonna ruin things. That was our one free guess. I'm gonna put this one here. And it's kind of hard to see the graphs, so I'm gonna color on top of them just so there's a little color shown on the screen if you want to do the same. Okay, so you're like, Miss Compton, are you serious? I was supposed to guess that this graph looks like, how was I supposed to guess that? And I totally understand. That's why we're talking about what we're talking about today. After today, you should be able to guess this kind of thing. And here is why. We are going to look at something called end behavior. End behavior. End behavior happens on the ends. So where do I see the ends? One lose a point. Where do I see the ends? Yeah, the arrows. So notice both arrows going up towards heaven on this one. Notice on this one, both arrows going down towards hell. So we're only talking about even degree ones. If our degree is even, so we're talking 2, 4, 6, 8, 10, an even number. If our degree is even, either both ends are going up or both ends are going down. Let me say that again. If our degree is even, like 4, 6, 8, 10, an even number, then either both ends of the graph are going up or both ends of the graph are going down. And you're going to say, well, how do you know if it's going up or down? It depends on that leading coefficient. If that leading coefficient is positive, aka it's bigger than 0, they're both going up towards heaven. If that leading coefficient is negative, they're both going down towards hell. So we look at the degree, like on our problem it was a 4, and it was a positive leading coefficient. That's why both of the ends are going up. We look at our degree was 6, but we had a negative leading coefficient. That's why both of our ends are going down. Are there any questions about that? Yes. Okay, so actually you kind of were already supposed to know that, and here's why. You don't have to note this unless you want to. We have already been doing problems for forever that were quadratics. You've had to do quadratic problems since, I don't know, chapter 4 is when we really hit those. You already knew from what we did with quadratics, the second you saw that positive 2 in front, was it a happy face or a sad face? You knew it was a happy face. When you saw that negative 1 in front, was it happy or sad? You already knew that. Hey, isn't 2 an even number? It was an even exponent. We had an even degree. Notice both the ends went up when it was a positive leading coefficient. Both the ends went down when it was a negative leading coefficient. And you didn't even know what you were doing back then. But there was a reason it was all working. Okay, before we go to odds and start talking about those, I am going to tell you one thing which will slightly make you sad. So you know how you're just supposed to know that x squared either looks like, it's called a parabola, and you're supposed to know it's either a happy or a sad face. You're supposed to know what the graph looks like that. As of today, you're now supposed to know what a fourth looks like. So if we had 3x to the fourth plus 2x, or plus 1, doesn't matter, or negative 3x to the fourth doesn't matter, you're either going to see a positive one or a negative one. And you know how I keep them straight? I think of letters of the alphabet. If it's x to the fourth, I'm either making the letter W or the letter M. If it's positive, I'm W. If it's negative, I'm M. So from now on, when you think of the fourth, either think of W or M. So on Matthew's next test, I'm going to give him some equation, and he's supposed to do a basic graph. If it's to the fourth, if I don't see a W or an M, but depending on that leading coefficient, he's going to get the problem wrong. He automatically is supposed to know fourth is W or M. Are there any questions about that? Okay, so I don't like to get confused, and this can be confusing in life. So I'm going to take those two graphs off, just so I don't think about them while I'm doing the next ones. When we get done, I have some tape. I'll gladly give your group to the dispenser. I'm sorry, I only have the one tape dispenser. If you're wanting to tape it down. Okay, so the other two graphs we're going to talk about today are obviously with odds. We dealt with even degrees and their end behavior. Now we've got to talk about odd degrees and their behavior. Now let's be honest, odd polynomials suck. And the reason they do has to do with their ends. What's the problem with their ends? They go in get the point. They go in different directions. What a pain in the rear. They go in opposite directions. This one's going down, this one's going up, this one's going up, this one's going down. They go in opposite directions. So odd, opposite. The end behavior is opposite. It's a terribly, terribly annoying thing. What's also annoying is it's kind of hard to memorize the shape of a cubic when it doesn't really look like a letter of the alphabet. So when I think of an odd, I think of a certain kind of animal. What animal do I think of? Yeah, if you said snake, get a point, because that was the obvious one. Yes, dear. Well, that one kind of does, but then what would the other one be? I don't know. I think snake fits it better. Okay, and so I'm going to focus on a specific part of the snake. I'm going to start at the left, like down at the bottom. So here comes the snake into the picture, and he's going he's going up the wall. So when it has a leading coefficient that's positive, because again, greater than 0 means it's positive, I think of snake up wall. When I see a leading coefficient that's negative, I start focusing on that. The snake entered the picture, and then what happened? He went down. So I think of the snake down the wall. Now, if you want to think of things a different way, you can. It's just the easiest way for me to remember. You know, is the positive cubic this looking in, or is the positive cubic this looking in? So the snake, when I start over here in the corner, if the snake's going up the wall, it's the positive leading coefficient. And if I start over here in the corner, my snake's going down the wall, it's a negative leading coefficient. Are there any questions about that? Now, again, was Travis probably supposed to guess this was cubic to begin with because there were 1, 2, 3 zeros? Probably so. There were also 3 zeros on this one. But we're not even talking about those zeros today. All we're focusing on is the end behavior, the fact that it's going opposite directions. And then we're focusing on that leading coefficient because either it's going opposite directions this way or opposite directions the other way. We need to know which way. Which leads to my last thought of the day. Well, not my last thought of the day, but the next thing I need to tell you today. So, sadly enough, not only do I expect you to know the graph of a parabola and the graph of something to the 4th power, so a coordinate function, I also now expect you to know something to the 3rd power. So if you see 2x to the 3rd minus 1, I expect you to know because it's a positive 2 in front, it's going to be a snake going up the wall. And from now on, if you see anything else that's cubed and it's negative in front, you better tell me it's a snake going down the wall. So you already knew parabola being the happy face of the side face. You're cool with the W and the M. The harder two are the snakes. Snakes going up the wall, snakes coming down the wall. That's my thoughts on the matter. Are there any questions about this? Again, we haven't even talked about zeros, and yet already if I give theoretically. If I give DJ a problem and it's a cube, he should be able to draw me a little quick sketch of a graph of what it looks like. No big deal. Okay, so if you're cool with this, let me show you how to fold it, because I know everyone likes to have their handout just so. And then let me give you your maze. Okay, you can tape your graphs down in their homes if you'd like to. You want to fold the white flaps in, so fold the left and the right flap in. And then you want to fold the words up. So basically it should say polynomial in behavior when you get done folding. Or else you fold it incorrectly. And again, I'm going to pass around the tape. So if you wanted to tape this little piece down so it wouldn't flap open, I would understand. Okay, Caitlin loves me enough. She's going to pass this out to you while she's passing it out. Let me explain. This is a polynomial in behavior maze. If you don't need to finish your test, this would be smart to go ahead and start. It's due on Friday, but honestly, you can get it done and finish it today. That would be smart. There's another assignment coming tomorrow and a checkpoint Friday. So the more on top of it you are, the better life will go, as always. In this maze, you start with the very top box, and you look at the polynomial they give you. For instance, your top box says 5x squared. That's a positive 5. So the leading coefficient is positive. The degree is 2. So when I'm thinking about the in behavior, I know it has to be both up. Thank you, dear. Which is why I'm going to go down to this box. And now I'm down in this box. Well, it's an odd exponent. Odds are supposed to go opposite ways with the in behavior. So it can't be that one or that one. It has to be this one. And if you keep following it around, thinking through in behaviors, you'll finish the maze. You do not use every single box. I think there's one box for sure you don't use. You do not use every single box. Okay, are there any questions about the maze? It's pretty straightforward, but let me know if you have